Singularity is an exploration of flight as well as body switching in VR. It is designed for the Oculus Rift. Our goal in developing Singularity was to explore what conventions were available to changing perspectives in VR through body switching. The players start the game as an astronaut in a small room. Upon entering the game, the player hears a voice come over the intercom. The ship's emergency messaging system informs the player that there is mechanical damage on board the ship. They must mind merge with a repair drone to locate and repair a damaged panel. We developed Singularity to research how people might perceive changes to their body while embodying non-anthropomorphic characters. We challenged ourselves to find ways of communicating this shift from one body to another using environmental cues and effective scenography. We encouraged players to transition between two modes of locomotion by implementing a universal threshold device, a virtual swivel chair mapped onto a physical chair in the playspace. Using the chair to rotate in place, as well as the robot's signature arm thrusters, the player is able to quickly fly through the labyrinthine spaceship and repair the mechanical damage they were warned about earlier. This interaction of transitioning between two bodies challenged us to find conventions of out-of-body experiences and body switching, and translate these to VR and away from other media such as films, while working with the limitations of the Oculus Rift. Very early on, we needed a way to communicate to the player what the robot body looks like before the mind merge, as well as a way to show what the original astronaut body looks like. We decided on separating the bodies using a clear glass window. This would give the player a full view of one or the other body, depending on which character they currently control. However, a glass wall that reaches from floor to ceiling appeared to many players as a place where they could walk, and many tried walking through the glass. During a period of user testing, testers reported that they felt encouraged to go right up to the robot. We solved this issue by replacing the glass panel with an opaque wall texture while still giving the player a small window to see the robot. Although other issues such as distracting object clutter still persist in the final iteration, this solution works from the astronaut's perspective, as the player is encouraged to view the robot body without walking through the wall. Narrative elements, such as effective sound design and shifts in perspective, joined with appropriate transitions, come together as an immersive VR experience aboard a damaged spacecraft. Welcome to Singularity.